Hey, Jonathan here. I want to do a quick overview of square roots, adding, multiplying, subtracting, dividing square roots. I guess the first thing to note is really what a square root is. A square root is the inverse function of a square. Just like division is the inverse function of multiplication, this is the inverse function of a square. So 2 squared is equal to 4, and the square root of 4 is equal to 2. One little thing I'll note on that, though, is that what this thing's saying to you is what times itself is equal to 4. So 2 times 2 is equal to 4, but negative 2 times negative 2 is also equal to 4. So there's actually 2 answers to the square root, both a positive 2 and a negative 2. A lot of the times we use the square root in the Pythagorean theorem, and we only keep the positive solution because we're talking about the length of a side of a triangle. But, when you are taking a square root, there will both be a positive and a negative solution. And then the other thing about a square root that you should keep in mind is you treat it really just like an x and a y. So the square root of 2 plus the square root of 3, well, that's like adding x's and y's. They are different things. They cannot be added. Square root of 2 plus square root of 3 is the square root of 2 plus the square root of 3, just like x plus y is equal to x plus y. However, if I had the square root of 2 times the square root of 3, that's like x times y, that's equal to the square root of 6, or xy. Okay, so that's really probably the most important thing to remember. You cannot add or subtract dissimilar terms. If I had 5 of these root 2's plus another 7 of these root 2's, well, what I'm saying is I have 5 of these things and 7 more of these things, so I have 12 of these root 2's. Okay, if I had, so that's kind of the key on addition and subtraction. And then multiplication, you can multiply across. If I have square root of 4 times the square root of, 15, that's going to be equal to the square root of 60. And then inside of there, I'm going to look for factors that are going to be pairs when I multiply them. And you could do this a number of ways. 60 is made up of, say, a 6 and a 10. A 6 is a 3 and a 2. A 10 is a 5 and a 2. Here's a pair of 2's. For every pair, 1 comes out, and it leaves me with a 3 and a 5 inside, which is 15, which kind of makes sense because I started right here, and I know the square root of 4 is equal to 2. So 2 root 15, or root 60, or 2 root 15, those are all equivalents. Okay, let's look at a few more square root problems here. If I have the square root of 5 root 175, and I want to simplify that, I'm looking for the factors of 175. Right? This 5 right here stays out in front, okay? And in this 175, I can see 175 is made up of a 25 and a 7. 25's a pair of 5's. Now that I have a pair, 1 comes out front. So that for this pair, 1 comes out. There's no pair for that 7, it stays in. And then here's my original 5 that I just brought down. And that works out to be 25 root 7. Okay, let's do another problem over here. Let's say I have 3 square root of 32 plus 5 square root of 36. And I can't add them because they're dissimilar, but let me see if I could simplify this square root. 32 is a 16 and a 2. 16 is a 4 and a 4. I have this 3 already out. Here's a pair of 4s. One of those comes out. No pair for that 2. It stays in. So this gives me 12 root 2. On this side, 36 is a 6 and a 6. That 5's already out front. There's a pair of 6's right there. 1 comes out. Nothing's left inside. And that just works out to be a 30. So I have 12 root 2 plus 30. And that's as far as I could go. These are dissimilar things, so they can't be added. Okay, let me try one more here. Let's say I have 4 root 75. Let's say 4 root 75 plus a 3 root 125. I want to combine those. I still have this 4 out front. 75 is a 25 and a 3. 25 is a pair of 5s. For every pair, 1 comes out. So I have this pair of 2s. 1 comes out. There's no pair for that 3. It stays in. I have this 4 still. So I have 20 root 3. And then let's do this red problem. 125 is a 25 and a 5, pair of 5s. 1 comes out, that 5 stays in, so I have 3 times one of those 5s, root 5, or 15 root 5. Again, dissimilar terms. Okay, let me do another problem here. It's going to be a little different. I have this 2 out front still. Bring that 2 all the way down here. 75 is a 25 and a 3. 25 is a 5 and a 5. Every pair, 1 comes out, so that 5 comes out. Stays root 3. So that gives me 10 root 3. Over here on this one, 48 is a 16 and a 3. 16 is a pair of 4s. For every pair, 1 comes out. I still have that 6 there. So I have 6 times 4 root 3. So that's 24 root 3. Now I'm saying I have 10 of these root 3s plus 24 more of these root 3s, or 34 root 3. So I could combine them if they're the same and cannot combine them if they're different. Okay, let's go over one other idea too on a square root. If I have the square root of x to the m to the nth root of that, that is the same thing as x to the m nth. So I could put that square root in a fractional form. So if I had the third root of x squared, that's equal to x to the 2/3. So that's how you could go from a square root symbol to a fractional form of a square root. So we got addition, subtraction. Same thing if I have 5 root 6 minus 3 root 6. I'm saying I have 5 of these root 6s minus 3 of them, leaving me with 2 of them, or 2 root 6. That would be my answer. Let's see if we have some multiplication. I have 5 root 6. Let's say that whole thing is times the root 3. That's the same thing as 5 times root 18. And then I could simplify that. That 18 is made up of a 9 and a 2. 9's a 3 and a 3. That 5 that's out front stays out front. Here's a pair of 3's. For every pair, 1 comes out. And then that 2 stays in. And that leaves me with 15 root 2. And that's simplified. I could always check these values on a calculator. Usually in math class, I like you to show all your work and do them as exact value problems. But 5 radical 6 times radical 3, that's equal to 21.21. And then 15 root 2 is equal to 21.21 as well. So I don't know if you can see that on the calculator. But you could always check your work on radicals with the calculator. Okay, well, hopefully that helps a little bit. That's just a quick overview on square roots and radicals. A lot of problems, a lot of applications of them. The one you're probably the most familiar with is from using the Pythagorean theorem, right, which is one leg squared plus the other leg squared equals the hypotenuse squared. So if I have 2 squared, this leg's 2, this leg is, say, 3, this is my hypotenuse C. I would have 2 squared plus 3 squared equals C squared. Sorry, that's the Pythagorean theorem. 4 plus 9 equals C squared. C squared equals 13. Then I take square root of both sides. The square root and the square cancel. I do that to the right side, I do it to the left side as well. So if this is 2, this is 3, this is the square root of 13. So that's probably the most common place you're going to see square roots. But all of these square root problems are all over the place on the SAT and any sort of standardized test. So again, if I may, just reiterate, the most important thing on these is to treat them like an X and a Y. Right? If I have 5 plus root 2 and 7 more of these root 2's, it's 12 of them. If they are dissimilar, root 2 and a root 3, I cannot combine them because they're dissimilar terms. Okay, thanks for watching. I hope that helped a little bit with square roots.